Let us look at these three examples of implicit functions being differentiated. We need to find the derivative in A. We need to find the derivative of 5y to the fourth with respect to x. B, the derivative of 3y to the negative 6 with respect to x. And C, the derivative of 7ln y plus 8 square root of y plus x square y cubed with respect to x. Alright, so what I want you to do is pause the video and work them out. So pause. Okay, good. You have paused the video and you worked them out. Now let's see each of them individually. d by dx of 5y to the fourth. So you have d by dx of 5y to the power of 4. Now, remember that when it comes to implicit differentiation, what you're really applying is the chain rule. So let us just be reminded quickly of what the chain rule says. The chain rule says if you have a function, call it u, and y is equal to something happening to u, right? Something happening to u, then dy by dx. So remember, u is equal to something happening to x, and y is equal to something happening to u. So dy by dx is dy by du times du by dx. An example could be y equals, let's say, x squared plus 1, and that is raised to the power of 3. Right? You say, let me rewrite these. It's x squared plus 1, and that's raised to the power of 3, right? Y is equal to that. Then you say u is equal to x squared plus 1, and then y is equal to u raised to the power of 3. So u is a function in x and y is a function of u. Even though you start out saying y is a function of x, you use substitution. So in this case, what you have is that dy by dx is equal to dy, the derivative of the outside function with respect to the inside function u, times the derivative of the inside function with respect to x. So this is the derivative of y with respect to u. So the derivative of the outside with respect to the inside, that's this one, and this one is the derivative of the inside with respect to x. U is the inside function. Now let's look at this. Y is a function because in this case you say y equal x squared plus 1, x cube, x squared plus 1 cube is a function, you know. It's a function of x. But you're saying that y is equal to that. So y must be a function of x. So this case now, y is a function, but something is being done to y. That means you have another function. So if y is a function of x, then 5y to the fourth is a function of y. So what you will find is the derivative of the outside function with respect to the inside function y, right? So what you want to do is find the derivative of the inside. Let's find the derivative of the inside function first. The inside function is y. What is the derivative of the inside function with respect to x? Well, the derivative of the inside function, since the inside function is y, is really the derivative of y with respect to x. And that will be multiplied by, so you notice, the derivative of y with respect to the derivative of the inside function, this part. U is the inside function with respect to x, but y is the inside function. Notice here, du, d of the inside function with respect to x. The inside function over here is u. The inside function over here is y. D of y with respect to x multiplied by, then we have the derivative of the outside function with respect to the inside function. So the derivative, if you should find the derivative of this, what you would have using the power rule is 4 by 5 y to the 4th. See that? This is the derivative of the outside function with respect the derivative of the outside function with respect to y. Why I say that? Suppose you had a is equal to 5y to the 4th, and I ask you to find dA by dy. What you would get is 4 by 5y to the, oh, this is 4 minus 1. Yeah, it's 4 by 5y to the 4 minus 1. So this is the derivative of a with respect to x. The derivative of the outside, this is the derivative of a with respect to y. A is equal to 5y to the 4th. dA by dy is 4 by 5y to the 4 minus 1. This is the derivative of a with respect to y. Now over here, what you have is the derivative of the function with respect to y. Alright? So you say 4 by 5 y to the 4 minus 1. Alright. So what you have here now is this. The derivative of y with respect to x times the derivative of a function with respect to y. So it is 4 by 5 y to the 3. 4 by 5 y to the 3 is 4 by 5 is 20. So let's write it 20 y to the 3 times, it's customary to write the dy by dx on the right hand side instead of the left, so let me put it over there. So what you have is dy by dx. So therefore, the derivative with respect to x of 5y to the 4th is equal to 20y cubed times dy by dx. So it's 20y cubed dy by dx. You don't necessarily have to write the times again. Could just leave it out there. So it is 20y cubed dy by dx for that answer. Alright, so let's go over it again. Remember, when you have a function of a function, you have the inside function, in this case you call it u, and the outside function. So just for clarification again, and to remember what this is about, here you will find the derivative of y with respect to the inside function, dy by d inside times the derivative of the inside function with respect to x. Now let's look over here. Y is the inside function and 5y to the 4th is the outside function. Here, if you should find d of the inside function by dx, you would be saying dy by dx. In fact, let me rewrite this and put the d on the left, the d inside by dx on the left times d of y by d of the inside function. So the derivative of the inside function with respect to x is this. Y is the inside function times the derivative of y with respect to that inside function for this one. This is the derivative of the whole function, if you want to call it a, b, c, and say a equal 5y to the 4th, and use a no problem. It's the derivative of the whole function, which we call a. It's like dA by dy, but we're not using any letter now. It's the derivative of the whole function with respect to y. So it's 4 by 5 y to the 4 minus 1. Remember here, if you say a is equal to 5y to the 4th, then the a by dy is equal to 4 by 5y to the 4 minus 1. That's what's happening up here. It's the derivative of the inside function y with respect to x times the derivative of the whole function with respect to y. So it's 5 by 5y to the 4th becomes 4 by 5y to the 4 minus 1. So this is just to highlight in detail everything that's happening in the background. Even though you can mechanically just remember that you should have 4 by 5y to the 4th times dy by dx. Anytime you have a y in the derivative, you must always multiply by dy by dx. But I want you to understand what's happening in the background and the reason why you do what you do there. Alright, so what we'll do is look at part B and C in a different video. So I will see you in those videos later.